Welcome to Geometry Pre-AP, greatest course in the world. Today we're going to talk about the volume of cylinders, cones, and spheres. So we are dealing with volumes of cylinders, cones, and spheres today, and any kind of composite shapes involving those figures also. So we're going to bring in this composite part also some more today. So just a little bit of vocabulary here. We're going to deal with just the parts of a solid, in this case a cylinder. So when it says what type of solid is, we know this is a cylinder. We know that the shape of this base is a circle. And we know that the radius here is AB. We want to know what is the height of this figure. It is segment BC. And so it says, is this a right cylinder? As long as the height and radius are at a right angle, then yes, it is a right cylinder. So height and radius at a right angle. Okay, and if it is an oblique cylinder, it works just like Cavalieri's principle said in our lesson a few days ago, that it's still the same volume as long as every cross section is the same area. So here we have a cone, and it says, what is the shape of the base? What type of solid is formed? And so there are questions. You want to pause the video and answer those questions, that'd be great. When you're done answering those questions, you can start it back up and you can see your answers. Okay, so I'll just bring this over right here, and there are all our answers right there for our cone. Just so that you make sure you understand your vocabulary. Expect there to be a right angle here because of height and the radius. Again, this is a right cone. And then expect to be able to do Pythagorean theorem or trig or special right triangles or any of those following information with a cone because you have that right triangle in there. All right, so here's our next one. It says, what type of solid is for? So again, we got another shape. Pause the video, answer these questions, and then turn the video back on and see how you did. Okay, so I'm going to move this over here, and there are answers there. Remember that a great circle is like if you were to slice this and you got the center of it, you would have to slice it just in a particular way to get the center. Basically like a equator or a prime meridian. That if you cut it a little bit above that or a little below that, you would actually miss the center, and so therefore it would not be a great circle. Okay? All right, so here are our formulas for today. The volume of a cylinder is big BH, but in a cylinder, we replace the base with the circle formula, which is pi r squared. For the cone, it's 1/3 big BH, just like a pyramid. But again, we replace the base with the circle that's there, so that's pi r squared. And we have our volume formula, 4/3 pi r cubed. Be careful of the r cubed. Remember that units for volume are cubic units. So we have an r squared, which is a unit squared, times another unit, which gives us the units cubed every time. All right, so here we're going to find the exact volume. So remember, I always want you to show your work. So volume is equal to pi r squared h. So we go pi 9 squared times 6. I would say the most common issue that we can have with these kinds of problems is I give you the diameter and you mistakenly label the diameter in there instead of the radius. Okay, so we multiply this out, you get 486 pi feet cubed. Get in the habit of putting those units. If you put those units in your homework, then when you take the test, you'll keep putting those units down and you will not mess up on that. All right, so here's a nice one for you to do. So you can pause the video for a second, work on this one, and then start it back up. Okay, so in case you had a problem with this one, that 8 squared of 3 is not the radius, that is the diameter. So since that is the diameter, I like to always label my radius as 4 squared of 3. So volume equals pi r squared h. When you're done with this problem, you should get 2,640 pi centimeters cubed. If you had some problems with that one, it may have been because you used the wrong radius and used diameter instead. All right, so here is a cone. We want to find the exact volume of this cone. Remember, our volume formula is 1/3 pi r squared h. In this problem, we do not have our h, so we're going to need to find our h. So 8 squared minus 5 squared equals h squared. Now, before I did that, I probably should have looked just to see, hey, is that a Pythagorean triple? You know, we use Pythagorean triples all the time if we want our answers to become integers. So teachers are always designing questions to make sure that you have integers there. Remember that we don't necessarily do that. So, all right, so when we work this, we get 64 minus 25 equals h squared. So when we do that, we get 39 is equal to h squared. So our height is the square root of 39. Check to see if that can be simplified. If it can't be simplified, then we're good to go. So our volume is equal to 1/3 pi 5 squared times the square root of 39. So we end up with 25 pi square root of 39 all over 3 is my exact volume. And so there we have it. So you may have to do that Pythagorean thing. You may even have to do trig there. It depends on the question. All right, so here's one that I want you to do. Give you a little hint before you start this one and pause the video. There is trig there because you have a 67.3 degree angle and you don't have the radius. So pause the video, work this problem. All right, so if you did this problem, your volume should be 502.814 meters cubed. If you got 85.858, you forgot to square the trig part. All right, so here we got the volume of a sphere. So volume is equal to 4/3 pi r cubed. So 4/3 pi 3 square root of 2 cubed. You might want to do that by hand. 3 square root of 2 times 3 square root of 2 times 3 square root of 2. So that's 27 times 2 times the square root of 2. So that's 54 square root of 2 when you square that part. So I have 4/3 pi 54 square root of 2. When we're done here, we end up with 72 square, well, I'll write that correctly, 72 pi square root of 2. And of course, that'd be units cubed. All right, so do this one to the side here, complete that one, and restart the video again. All right, so if you got this one done, and you're finished with this one, the volume here will be 36 pi all over 125 inches cubed. All right, so let's go to our next one. So here we got a problem that's a oblique cylinder. So I want you to pause the video here and make sure you do this oblique cylinder. All right, so once you're done with this, and our volume is going to be pi r squared h. So our volume is going to equal here 112 pi centimeters cubed. Remember that the height is 7 is no longer the lateral edge for the cylinder. All right, here's another oblique one. So pause the video, work this one also. Okay, so for this one, I'll accept two different answers, 21.78 pi centimeters cubed, or as a fraction, 1089 pi over 50 centimeters cubed. Because the decimals are terminating, you can use them in this case. All right, so here we have our complex shape. So we're going to find the volume of this one. So the volume of this figure, I like to always write it first, is 1/3 pi r squared h plus pi r squared h. So our volume is equal to 1/3 pi. Our radius is 3 squared. Our height is 7. All right, no, actually, we need to go in. All right, our height here is 3 for that cone, plus pi 3 squared, and our height here is 7. So this 1/3 cancels with this 3, so we have 9 pi plus 63 pi, which will be 72 pi centimeters cubed, which is our volume. So always write your formula first and plug all your information into your formula. All right, so pause the video for a minute and do this one. All right, so for this one, you should have 132.651 minus 11.05425 pi. Now, for a problem like this one, I'm probably going to ask you to give me an answer round to nearest thousands or something like that because there's all these decimals and radical or pies and stuff like that. So be able to take that answer, put it in a calculator, and get a decimal to the nearest thousands if you can. All right, so here's another problem that has an exact. I would like you to do this one also so we can practice this one. All right, so when you're done with this one, you should get an answer of 56 pi meters cubed. Remember, take the volume of the small cylinder, subtract it from the volume of the large cylinder. All right, here we have another one. I'll tell you what, this one, let's not do exact. Let's do it to the nearest thousands. Pause the video and do this one. Okay, when you're done with this one, you should get 563.208 centimeters cubed. All right, that's the end of our video. So make sure you have all those notes you have in class. If you had any problems with the questions, bring those back to class, and we will answer those when you come into class on Monday.